So as you have been looking the ways of solving quadratic equations, we started with the first one, that using factor method. Now we are moving to the second one, which is completing square method. We'll try to see on our whiteboard, completing square method, we're going to be moving together. Consider the identity x plus b squared. When you expand it, it means it's going to appear 2 times. You will come out with x squared plus 2bx plus b squared. It indicates that adding the term b squared on this one here, adding b squared on this to the expression this, it is going to make it a perfect what? Square, so that it can easily be factorized. But when you don't add the b squared, it can't become a perfect square. So that's what we are coming to this. The procedure involves the procedures which we are going to be using when we are completing square. The first one is x squared must have a coefficient of 1. Even if you find that x squared has a coefficient of 5 or 2, first divide it out by 2 throughout to make sure that x squared bears a coefficient of 1. I'm repeating this one, we don't complete square when x squared is having a coefficient which is more than 1. So x squared must have a coefficient of 1. Then the completing square will go on. Then from there, the coefficient of x, like here, this is x squared. We've already said that for computing square take place, x squared must have a coefficient of 1. Then to the coefficient of x, it is always being divided by 2. So we add half to it, as you're going to be looking in our examples, which you're going to be taking on that. So the first one I would say express, example 1, express x squared minus 5x plus 8 in the form of x plus a squared plus b. One first express x squared minus 5x plus 8 in the form of this one. So can this one, when they say in that form, they are meaning apply completing square method. So what we're going to do is this, x squared minus 5x plus 8 equals, now you can see x squared has already a coefficient of 1. That means we are free to go on with the idea of completing our square. Then with the coefficient of 5x, we said on that one, you divide it by 2. So what we're going to have, we're going to have x squared minus 5x, we say out of 2. What you have done, you also add on it, we say plus 5 out of 2, the whole of it, but remember it is a negative, we say plus that negative squared, then there is also a plus 8. So from there, what do you write? We are only going to write, this one is already now a perfect square, we shall only write x minus, that one as it is, minus 5 out of 2, the whole of it squared. What does it mean? When I expand the whole of this one, when I expand this one, I will come out with this. Then I say plus 8. So since they have said we put it in that form, it is the same as x plus negative 5 out of 2, the whole of it squared, then plus 8. If they say, hence state the values, I'm free to say, therefore, a equals that, b equals that. So that's what we normally do to this. So I've already expressed in that one. So we are going to be using the same ideas to solve the following, or to solve the following of that. So if we move on, we have already said that after doing that, we have only added it to that. We still add it here, plus, when you expand this one becomes 25 out of 4. So after subtracting, such that when you add, the same goes on. So when you find the LCM here, what does it become? What is the LCM here? I've got x minus 5 out of 2 squared plus, what is LCM is 4. 4 divided by 1, we are getting a 4. 4 times that, we are getting 32 minus 25. So what does it become? X minus 5 out of 2 squared plus 32 minus 25, we are getting 7 out of 4. So this one is already expressed in this form which they want. I can even say which is in the form of x plus a squared plus b. So when you compare, it means a equals negative 5 out of 2 and our b equals 7 out of 4. That's what happens to that. If they say express that in terms of that, that's what will automatically come out. So let's take now with examples of solving. That one was about expressing. So let's start with example 2. Example 2, and say using completing square. Using completing square method. Using completing square method. Solve the equations. Solve the equations. At a, x squared minus 7x plus 10 equals 0. So what I'm going to do is this. Now the offset is equal to 0. What you do, you can first take this one to the other side. Take this one in the other side. It's going to be x squared minus 7x equals, that is a positive when it becomes a negative. So we said on the coefficient of x, you divide it by 2. Again, you add it on both sides. So what I'm going to do, this is going to be x squared minus 7 out of 2x. Then what you do, you add that one, the way it is plus negative 7 out of 2, the whole of it squared. Whatever you have done here, you need also to do it in the other side. It becomes negative 10 plus negative 7 out of 2 squared. So this one is already now our perfect square. So what do we write? We only write x minus 7 out of 2, the whole of it squared equals negative 10 plus, this is 49 out of 4. So we get the LCM. What is the LCM here? Is 4. 4 divided by 1, you get a 4. Times the 10, you get negative 40 plus 4 divided by 4, you get 1. Times that, you get 49, which becomes 9 out of 4, which is equal to x minus 7 out of 2, the whole of it square. Then, how can we remove this square root? How can we remove this square? Is by taking the square root on both sides. Take the square root, take the square root. This one disappears with that. So we are going to remain with x minus 7 out of 2 equals, what is the square root of that? The square root is plus or minus 3 out of 2. This one is a negative. When it goes there, it becomes a positive. So x equals 7 out of 2 plus or minus 3 out of 2. What does it become? The LCM is already. That means x equals, you can even add 7 out of 2. You can start by saying either x equals 7 out of 2 plus 3 out of 2, or x equals 7 out of 2 minus 3 out of 2. We go ahead. For the first one you add. What does it become? This plus this, you get 10 out of 2, which is equal to 5. For this one you subtract. Since the denominator is the same, we just subtract the numerator. 7 minus 4, 7 minus 3, you get 4 out of 2, so our x becomes 2. Therefore, x equals 5 and x equals 2. We have already solved that one. So we are going to go on and vote. That was part A of the example. So we are going to go to part B. Part B. We are going to move to part B. Still using completing square method to solve the following quadratic equations. Part B was that y squared minus 13y plus 24 equals 0. So want to look at that. What do? The first step is take this one into the other side. So we are going to have y squared minus 13y equals negative 24. Getting that because that is a positive. Then here we use our applications of dividing by 2. We are going to have y squared minus 13y out of 2. What you do here, you add plus negative 13 out of 2, the whole of it squared. What you do here, you also do it in the other side. Negative 24 plus negative 13 out of 2, the whole of it squared. So what does it become? So this becomes y, it is already perfect square. You just say y minus 13 out of 2, the whole of it squared, equals, we expand, negative 24 plus 169 out of 4. We can find the LCM. So what is the LCM here? Is 4. 4 divided by 1, you get a 4. Times 24, you get negative 96 plus 4 divided by 4, you get a 1. Times that, you get 196. So we are having y minus 13 out of 2, all of its equals. When you try to subtract that, when you try to add, you can even do it as our side work. 169 minus 96. Here you are getting a 3. Then this is 16. When you are getting 16 minus a 9, it remains as our 8. So it becomes 83. So this is equal to 83 out of 4. Then from there, you are free to take the LCM. You can go ahead and take the square root on both sides. This one disappears. So I've got y minus 13 out of 2 equals plus or minus. Then you are free to substitute in on your calculator. Then you do the applications. So this one will be plus or minus root 83 out of 2. This is a negative. When it goes there, it becomes a positive. So y equals 13 out of 2 plus or minus root of 83 out of 2. So you are supposed to go ahead and say either you take the for addition and or you take when you are deducting. Then from there you come out with the clear answers on that one. So let's go to part C. Part C of it. We're now moving to part C. We're now moving to part C. of same way of solving but using completing square method. Part C goes to x squared minus 5x plus 3 equals 0. I wanted to bring out this example when x squared is not having a coefficient of 1, and we see how best can we handle a number related to that one. So what you do, the first step is first divide throughout by 2 so that you can remain with a coefficient of 1 on x squared. So I've got 2x squared minus 5x plus 3 equals 0. We divide throughout by 2. Divide throughout by 2, we are going to have x squared minus 5 out of 2x, then plus 3 out of 2 equals 0. Divided by 2, you get a 0. So this one is a positive. When it goes there, it becomes a what? It becomes a negative. So I've got x squared minus 5 out of 2x equals negative 3 out of 2. Then here we apply our application of dividing, the rule of dividing by 2. So here we have got 5 out of 2. We are going to divide it by 2. It's going to become 5 out of 2 times 1 out of 2, which will become 5 out of 4. That one was our side work. So I don't want to see people asking why has it got 5 out of 4. So it is a rule on this one that this number we divide it by 2. So we are having x squared minus 5 out of 4x. We say plus negative 5 out of 4, the whole of it squared. What you do here, you also do it in the other side. Negative 3 out of 2 plus negative 5 out of 4, the whole of it squared. What does it become? This one now is already a perfect